So we know that if we're going to make a quantum computer, it seems like you need to make individual particles interact and kind of talk to each other. And there have been proposals showing that you can do this without using any sort of direct interaction between the two photons. In any case, if we could create a direct interaction between two photons, this could lead to maybe an easier solution, an easier way to realize interactions at the quantum level. So what we're working on in this project is looking at different sorts of nonlinearities and trying to characterize them with the goal of going to the quantum level. And in particular, what we're focusing on right now is graphene nanoplasmonics and trying to use the nonlinearity in graphene nanoplasmonics to reach this quantum level.
So we are characterizing the graphene nonlinearities to achieving the long-term goal single photon generation within graphene. We are seeing an enhancement compared to planar graphene in graphene nanostructures, and we are working in this direction to achieve a photon-photon interaction within the graphene that is needed for universal quantum computing. But we are more interested to the electronic properties, and so the optical nonlinearities is related to the fact that there are a lot of free electrons within the graphene that reacts with the light that can impinge on the medium.
Yeah, so graphene is a material consisting of carbon atoms, and what's kind of remarkable about graphene is you would think if you want to make light interact with the material, you need a thick material so that you have a lot of chance for each photon to interact with the atoms in this material. However, it turns out that graphene in a single layer already has a very strong nonlinearity. What I mean by nonlinearity is this is the mechanism that two photons can kind of see each other when it goes through the medium. So you can have this single atomic layer of graphene and send in two photons, and the fact that there's one photon in the material makes the second photon behave differently. And this is roughly what we mean by a nonlinearity. This project started through a European project, I think about 4 or 5 years ago. And our original task as part of this project was to develop a detection system which was able to detect single photons emitted from these structures. So we've since done that. We've built up our detection system, and now what we're working on is really characterizing the properties of the graphene ourselves. So now we're in a situation where we get high quality structures through this collaboration with this group in ICFO, and they send them to us, we measure them, and we have a bit of back and forth trying to design optimal structures to achieve this single photon level nonlinearity.